Just spend a moment to focusing on the types of solutions we have. And we notice that when we find these roots of our spring mass system, which looks like this as an equation, when we found the roots of r squared plus b over m r plus k over m equals 0, that was our auxiliary equation. That's our auxiliary equation. Then we found that we had to use something like the quadratic formula. Now that's going to be negative of the b value, which is b over m, plus or minus the square root of the b value squared, so that's b over m quantity squared, minus 4 times a times c, all over 2a. Now the number of roots is really what we're after here. When we have, the way we determine the number of roots is by this thing that we call the discriminant. So this thing here, this quantity under the radical, this is called the discriminant. And depending on where that is, relative to 0. So if this quantity down here is bigger than 0, that is, it's a positive number, then we're going to have two real solutions. If this number is negative, then we're going to have complex solutions, and if it's equal to 0, we're going to have a repeated root. Then we'll have negative b over m plus or minus 0 over 2. And negative b over m plus 0 and minus 0 produces the same result. So if we look at that and we ask ourselves, okay, when will this quantity be negative? So if we look at when will b over m squared minus 4 times k over m, when will that be negative? Well, in terms of the b value, if I do a little bit of algebra on this, I see that this is b squared over m squared, which is less than positive 4km. Right, so if you add things about the inequality, it still maintains the truthfulness of the inequality. If I multiply both sides by the square of mass squared here and mass squared over here, that's a positive number, so that's not going to change the sign of our inequality. The masses will cancel out here, and that will lead me to b squared has to be less than 4 times k times m. So if b squared is less than 4 times k times m, or 4 times m times k, we have what's called underdamping. B is small relative to m and k. Now we saw an example of underdamping here. This is called underdamping. And this happens precisely whenever you end up with complex roots. So you'll have complex roots, and your solution will be of the form k1 e to the at sine bt plus k2 e to the at cosine of bt. All right, so that's going to be the underdamped situation where you're going to have some oscillation. And that leads to complex roots. So we call this type of system an underdamped system. Now, overdamping is usually whenever your damper is really large and causes your spring mass system to immediately return to rest. That's going to happen anytime you have real roots. So if we just change this to a greater than sign, this means that the system is going to have two real roots. And we already know that if we have two real roots, our solution is of the form k1 e to the r1t plus k2 e to the r2t. And that's going to be called an overdamping of the system. And so that's going to be, again, so up here, our graph visual will look something more like this, where you do have decay, but it takes a little bit of time. With two real roots, the example we encountered is where something like that, where it almost immediately stabilizes out, or doesn't oscillate whatsoever. Now this is the case that we won't really cover. This is called critical damping, and this is where B is just between over and under damping. Here we have two real roots, but they'll be repeated roots, because if b squared is equal to 4mk, what that means mathematically is that if that's the case, then this square root will be 0, and then you'll have two repeated roots, where your roots will be r1 and r2, but they'll all be equal. And we're not going to prove this right now, we're not even going to work with this solution, but whenever you have the same root twice, it doesn't make sense to just write e to the rt plus k2 e to the rt, because that's really just one term. So it turns out that if you have a repeated root, it can be proven that the second solution will be t e to the rt. We're not going to focus too much on this, but you can see cases of where this will happen.